Hello guys, welcome to today's class. Today we'll be looking at partial derivatives. Partial derivatives is still the same thing as partial differentiation. So partial differentiation is another form of differentiation whereby you differentiate in respect to another variables. So for example, we have y when y is equal to f of x, and this is still the same thing as dy dx, and another way of writing dy dx is still y prime of x. So now in partial derivative, the d is not as the normal differentiation when take like the normal differentiation. So the d is form of like a curvy d, just like this, curvy d, just like this. So now if we have y equals to f of x w z, so now how we differentiate? We say we differentiate y respect to x. That you will differentiate what y. This is how you read this. You differentiate what y, the function y in respect to x, also the function y respect to w, the function y respect to z. So we all know the normal differentiation, like the formula method. You have, for example, you have y equals to x raised power 4, and if you are differentiating y respect to what x, this will now be n times x raised to n minus 1. So this is the normal one. And let's take an example. We are given, say, let f of xy be equal to x cubed y minus xy square. Now find one, the derivative of f respect to x and f respect to what y. Now this, you differentiate x, take y as what constant, leave y as a constant, differentiate x. For example, if we attempt the first one, okay, let's call this an example. So now if you attempt the first one, we differentiate this function. So now we differentiate x, leave y as what constant. So differentiate x, you have 3x square y, 3x square y. We are leaving y as constant. We are differentiating only x. We are differentiating respect to what x, leaving y as what constant. So now this other one, if you differentiate this, you have y square, because if you differentiate x, you have 1. So 1 times y square still y square. So this is for this. The second one, so now if you differentiate respect to y, differentiate y, now you have what, x cube, because if you differentiate y, you have 1. The answer is 1. So if you want multiply 1 by x cube, still the x cube. So minus differentiate y square, you have what, 2y. So here you have what, 2xy. So this is your answer. Okay, now let's take another example. So say if u is equal to 2xy square plus 4y z square minus x square. Find number 1 du dx, du dy, number 3 du dz. Now we are asked to, it said if u is equals to 2xy square plus 4yz square minus x square, find what? Differentiate, that is find du dx. Number 2, find du dy. Number 3, find du dz. Now solution. Number 1, u is equal to 2xy square plus 4yz square minus x square du dx. Now remember, we are differentiating x, keeping other terms, other variables as what? Constant. So if you differentiate x here, we have what? Only a 1. So we have what? 2y what? Square. Plus, is there x here? So there is no x here. We'll just assume everything here is what? 0. Now if you differentiate, okay, we'll just assume everything here is what? 0. So if you differentiate now, minus x, let me put 0 here. Since there's no x here, put 0 plus. So if we differentiate what? Minus x square, what we have? We have what? Minus 2x. So the answer here is what? 2y square minus 2x. So this is your answer for the first one. The second question, du dy. So this is what you were given, plus 4yz square minus x square. So now we are differentiating respect to what? Y. That we differentiate to what? Y, keeping every other thing as what? Constant. So now if you differentiate this y here, we have 2y. We have y square here. So if you differentiate y square, you have what? 2y. So if you multiply 2y by this, you have 4xy plus y here is 1. So if you differentiate y here, you have 1. So plus what? 4z square. Is there y here? Since there is no y here, we'll take it as what? 0. So this is equal to 4xy plus 4z square. This is your answer. Now for the third question, we are asked to differentiate u respect to what? Z. So now we have this, what we are given is 2xy square plus 4yz square minus x square. Now if we differentiate, we are differentiating what? Z, keeping every other thing as what? Constant. So since there is no z here, we keep here as 0 plus z square. If you differentiate z square, you have what? 2z. So 2z, 2 times 4 gives you what? 8. So what we have here is what? 8yz. There's no z there, keep what as what? 0. So our answer is what? 8yz. This is the answer. So now this is how to differentiate using normal formula method. In our next class, I'm going to teach you how to differentiate using what? First principle method. How to differentiate partial differentiation using what? First principle method. Please like, share, and subscribe. See you in our next class.